Question 22. 30 centimeters cubed of xenon and mixed with 20 centimeters cubed of fluorine. They react like this. 1 mole of xenon reacts with 1 mole of fluorine to make 1 mole of xenon difluoride XeF2. Now, for gases, volumes can are the same as, or can be treated the same as, moles. So let's say 30 centimeters cubed react with 20 centimeters cubed. 30 moles, you could say, react with 20 moles. That's not entirely true, but in terms of ratio it is. So we've got 30 moles of this reacting with 20 moles of that, or at least the ratio is the same. So I've got excess xenon and 20 centimeter cubed of fluorine, 20 of this. So 20 centimeter cubed of this would react with 20 centimeter cubed of that and leave 10 centimeter cubed left over. Now 1 mole of this reacts with 1 mole of this to make 1 mole of this. So 20 centimeter cubed of this would react with 20 centimeter cubed of this to make 20 centimeter cubed of this, and making 20 centimeter cubed of xenon F2. All of my 20 centimeter cubed of fluorine have reacted, so that's gone. 20 centimeter cubed out the xenon have gone, because 1 mole of this reacts with 1 mole of this, or 20 centimeter cubed of this reacts with 20 centimeter cubed of this, and I've got 10 moles of xenon left over. So I've got 10 centimeters cubed of this left over. I've made 20 centimeter cubed of this. 10 add 20 is 30 centimeter cubed. Which of the following solutions would react exactly with the solution containing 0.05 moles of sulfuric acid? Well, first of all, I've got to work out how many moles of each of these I've got. I've got centimeters cubed. I'm going to divide by 1,000 to get into decimeter cubed. And then what I've actually got is I've got concentration is moles divided by volume. So moles is concentration multiplied by volume. Once I've divided all these by 1,000 and multiplied by these numbers here, I've got concentration multiplied by the volume in decimeter cubed. I've worked out the number of moles of each of them. So the number of moles of A is 0.05, number of moles of B is 2, number of moles of C is 0.2, and number of moles of D is 0.05. So if it's reacting 1 to 1, 1 mole of this is reacting with 1 mole of this, then I'm looking for 0.05. 0.05 of barium sulfate, so this could be a possibility, or A is 0.05. So I could be looking at either A or D as a start. I need to know which one of these, barium hydroxide or potassium hydroxide, reacts in the ratio 1 mole of this to 1 mole of sulfuric acid. Well, I know that a sulfate ion made from sulfuric acid is SO4. It's 2-. A potassium is a 1+ ion because it's in group number 1. It loses 1 electron. So I'm going to need 2 1+ to balance the 2 minuses. So this K2SO4, 1 mole of sulfuric acid will react with 2 moles of KOH, because I'm going to have to balance it with a 2 in front of the KOH. So this is going to react 1 mole of sulfuric acid to 2 KOH. So my answer isn't A. My answer might be D. Does 1 mole of barium hydroxide react with 1 mole of sulfuric acid? Well, barium's in group 2, going to form a 2+ ion. Sulfate, as we've said, is SO4 2-. So 1 Ba reacts with 1 SO4. So 1 BaOH 2 will react with 1 mole of sulfuric acid 1 to 1. So 0.05 moles of sulfuric acid will react with 0.05 moles of barium hydroxide, and we've discovered that D has got 0.05 moles of barium hydroxide to make barium sulfate. The answer is D.